Hi, my name is Mads Barnkop from Kaizer Power Electronics, and this is my lovely daughter, April. Okay, I have to just interrupt this introduction to our robot building video because 4 years ago I did not imagine that this project would take so long and cause me so many problems, and also just fitting something that complex into a daily life with kids, house and normal work. So what you're about to see is what has been cooked down from some 20-30 hours of raw footage. I hope you like the result and enjoy what it is like to building a complex robot along with a 6 to 9 year old kid, because that's how long we spent building it. Last year we built this line follower robot, or I would say that she actually built this because she did most of the soldering at the age of 5. She's now 6 years old, and we have gotten hold of one of these Petoy robotic kits.
En katrobot, der kan gå selv, og vi skal til at lave den lige nu.
Let's get the box opened. Here at first we have a picture of what the robotic cat would look like. Thank you for adopting Nibble. And I will have to say that this is not a sponsored gift to me. I bought this without any previous, without telling the creators of this that it's going to be built and tested and such on video. So there is 3 small cardboard boxes, and we have all the laser cut wooden parts down here at the bottom. Now the servomotor box. What's in here? Small mini USB cable, some different mounting hardware, and 6 servo drives in this one and 5, so 11 servo drives in total. Then we have another accessory box. Could you open that one? Here we have some of the different plastic parts, small file, battery holder, lots of springs, remote control, control board, ultrasonic sensors, and then April will unpack the NY board, which is the small anonymous control board. So that could have been some anti-static, but that's just regular bubble wrap. That's not okay. So we have a microcontroller sitting in the middle there. There is all the connectors for the different servo drives and sensors, if there is any. At first I thought that we were just going to print a little instruction and then put this kit together. Now it turns out there is only a online description of what to do. And it has one here that says open the box. It has markings for all the different parts, what they are for. And we can see that we do have some of the head parts here and over here, and we should have the chin. Now I can also quickly notice this is a different kit. That's not even that picture. God, how wonderful. So I guess we have to figure out a few things ourselves then. 5 types of screws, different servo motors. We have to start with the head. Two hinges, a base, the nose, the cranium, the ears, the eyes, the jawline. So at first we actually have to prepare our ultrasonic sensor. We need to solder in the resistor, the infrared, it's an RGB LED, a resistor for it, and some wires so we can solder it into the small control board. So I'll solder that on and give that some more shrinking tube. All while doing so, April is using the small file to remove all the gratings from the wooden parts. This is a bit more advanced kit than I first anticipated. I must say that I naively thought this would be much easier and perhaps a kit where she could participate much more with the assembly than what it looks like right now. Getting the LED ready to mount inside the eye patch here. At first I made it a bit too long, so it was up against the crystal here. That gave some problems with missing distances, that it simply took up too much space inside the head. Another problem, that it's a bit too short, so I had to carve out a bit of the piece of wood here in order to make it fit well enough to inside the cranium here. Not at all for a 6-year-old, unfortunately. It is a funny puzzle to sit and put together, but if you have not tried it a few times, I make this look easy right now because I put this together like 5 times already and had to take it apart again because of the LED was not fitting, giving me some trouble again. Jam this one in place. This should get locked up with a servo motor here at the back. Now that we have the head assembled, we need to put in a servo to lock it together. You look down here at which servo to put in. It doesn't even say, so you have to scroll up, find out that it's a MG90D servo. Servos are completely identical. Only difference is cable length. Scroll down to the servos and there we have it. And then it of course says that the new edition has short cable, long cable, whereas it's called MG90D with a long cable in the old shipment, which the instruction is written for. So it takes a bit looking back and forth before you find out that you can also see here that longer cables are used for head tilting and for knee joints, whereas the shorter cable are used for neck, tail and shoulder joints. It has been 2 weeks since we last put the head together. The servo motor is now in place and the wires for the ultrasound sensors are in place. The 2 weeks that went, we got to order a Raspberry Pi version 3 Model B+. That came in the meantime, and also ordered 4 batteries because this actually uses 2 14500 type lithium-ion batteries. And I just assumed this was AA batteries when I looked at the battery case. We are putting the neck together today and possibly some more of the body frame. We'll see how far we get. This is not the same pieces of plastic. We have a newer version of the whole kit, so definitely have to pay attention to that because that seems to have a lot of parts changing in the newer versions of the kit, and the guide always have that mentioned on the bottom of the step. It's kind of weird because for the thigh and head it shows you only have to cut the first hole in one side. But if you look here, they actually cut in both sides but at second hole. There's a few inconsistencies in this. Pew! Building robots is dangerous. So now we have to mount the neck to the head. Really takes a little looking back and forth, and also it doesn't seem to have anything to actually fasten the neck over on the other side of the servo here. I'm not quite sure if it has to... Oh, this is really some small parts, everything requires a lot of force, and it's really tiny parts. For the rest of the body, the mounting instructions are sparse, to say the least. So you just have to break out those things. Pay attention to something that's painted red. They should have laser cut the part numbers onto them. That would have been nice. Now it says here, on earlier batches of knife boards, the manufacturer used taller jumper pins than expected, so it will be necessary to bend pins or otherwise modify the knife board to fit a pie on top and use the pie stand. There's a list of suggested solutions. Ugh, what is that about? Sign up to view this category. Oh, you gotta be kidding me. Kidding, haha, cat. You get down to a do not connect the head with the neck yet, because the tilt servo on the head has to be calibrated. Yeah, well, that's great to write underneath the whole assembly part. Have to read this whole guide twice or 3 times, and then you forget half of it anyway. April is keeping track of all the parts. This is requiring some puzzle skills that are unfortunately above the skill or where you can participate with a 6-year-old. Unfortunately, it's the parts are simply too small and the instruction is way over the level of, yeah, I would say even for me it's getting hard to understand. I have to jump back and forth all the time. So I have to take it apart again, get those wires out through that hole, vice versa on the other side. This is some puzzle. This is not just building a cat robot, this is building a cat robot 10 times. Because everything is put together, taken apart, put together, taken apart, put together, taken apart. It's really back and forth all the time. And by now I have long lost the attention span of my 6-year-old daughter. April has left, and now my son is also awake. This is absolutely the joy of being a family and trying to build advanced stuff like this. You have so little time, so little attention span, and it's hard to get anything done really. But very clever design, I must say that, because it's very very tightly fit together everything. But that makes assembly very hard. But here we have it. The body is now put together and we will take a break. So that should be one thigh and shank. So if we said that was our first left leg, then we would like to have one pointing opposite, like that. So we need to cut more. Where's the cutter? Always placing the tools in all kinds of places. A good 3 weeks has passed since we last made some progress on the robot project here. we got the 2 shanks put together the last time. So now we will finish the other 2 here. And April is also here, as you can see. Her hands are here, yeah. She has all the toys, some pinches, yeah, and she will organize some of this wood stuff. What on earth is going on? Why is that magnetic to my laptop? Oops. Seems to be some kind of lit sensor in the laptop there. Did not see that one before. We're now at a point where we have assembled the whole frame, all the legs, the head, the neck, the tail. We have the calibration thing, and now the next part is configuration. It tells you to go and read the user manual for the board version that you have, but that is generally just a list of limits and specifications, layouts of the different ports, and does not really tell you anything to do. So it is still all over in the assembly instruction here. So as we pass down through all this, it says that if we use the metal servos that came with the kit, we can skip the whole potentiometer servo voltage calibration, as they just use the voltage directly from the batteries in order to give it the most power possible. Then we have to do a lot of downloads now, so we'll have to switch over to the PC and download all the software, the different programmers, and the whole package to control the CAD, the software for the CAD, the OpenCAD framework. And also set up our Raspberry Pi and test the battery connection. Then we get to the connect wire chapter, which also describes all the different pinouts and how to connect the wires, which goes where. And here we can actually see that the CAD is shown with its legs, tail and head attached, and how you put the wires in. And then we get to the calibration chapter, and again have to enter some calibration mode through a terminal. And then we get to a chapter that says attach head, tail and legs. So we have to scroll down 2.5 chapters before we find out that we are not going to attach anything yet, but on all pages it looks like that we have to in order to program it. So we really have to read out in front. We have learned that quite early in this project. Now we are at the configuration of the CAD. So we have the different parts that we have already assembled. We have the
leg, head,
and
body.
Apparently there is a new version of the new board. We have the new board version 0.2, but there is also a 1.0 now, which seems to have some better features and is more developed. Certainly seems more complex than the one we have. Now we get to downloads and installations. So first we have to look into getting all the right libraries into our Arduino program here. Library manager. Let's just get it anyway. Alright, so we have our libraries updated. That's a lot of settings to come down. Wow. And it failed. Now what? So just a bit more reading, and actually says you just have to unzip it and then add some of the libraries that we need: the MPU and I2C dev. So let's try that again. Okay, library added. That's good. We should see that we have those down here now. That looks fine. We have the version 0. something that runs at 20 megahertz. We need to add a customized configuration file. Very nice. What are you doing? Updating software packages and libraries is not a good kind of entertainment for 7-year-olds. We did, however, also start this project while she was 6, so yeah, time flies. What does that even mean? I am so unsure. And we do have the red programming board. I have that here. Now we just need a programming cable, and we can connect, and let's see what happens. We have power LEDs on, also on the Raspberry Pi. Now why does it set new board 0_1? That's wrong. We have to test buzzer first. We can do that. It's quite nice that's actually included with some test programs. Where is that even located? Open up the serial monitor. Okay, so just a lot of failures right now. So we have to compile the code, upload the sketch. So writing, reading, done. And there we have it. A nice little buzzer beeping program. We have some X-Tar rechargeable 14,500 batteries, so April will now unpack those. Of course, if you reverse the connection of the battery pack, you will damage the board. We set out on this project 2.5 years ago. It's been 1 year and 2 months since we did some work on it last, and good things comes to those who wait. In the meantime, the developers of Nibble have released a pet toy desktop app and also released wireless modules, which now can use Wi-Fi and Bluetooth, so we can connect it up to April's tablet. So the cat has been living in the project box for a good while, so let's get it out. Okay, so let's get the app installed. Let's see, what does this do? Redirect us to the introduction to the app. The major function modules are firmware uploader, joint calibrator, and skill composer. That's actually quite nice because before skill composer was just editing large arrays of data. So that's quite nice if they did make that one easier. And I would like a pre-compiled binary. Let's run the user interface here and let's see what happens. Okay, so we get some kind of small program here. We can choose Nibble or Biddle, which is the smaller robot dog. Probably like it in English. So let's take the firmware uploader. Choose the release folder. Okay. 1.0, 2.0. Nibble, and I think we have the Nibble board 1.1. Say new boards version 0.2. So I'm not sure what that means. I know that means reading more in the manual. Okay, so that kind of sucks. There's no reference to the old board. What can I actually choose in here? New board. What is this? Software version 1.0. Feels like this does not work for our older version then. Now I feel sad. So it took a bit of digging to find the older documentation for the software 1.0 and also find out how to use the new board 0.2. But as this involves some Arduino programming instead of just using a firmware uploader, I think it's time for some coffee. Because I got a feeling this is not going to be just like that. And certainly not with an 8-year-old sitting next to you expecting a robot to jump right away. Let's get Arduino IDE fired up. Deactivate while adding. I'm pretty close to just should be ordering a later version of the new board and just don't have to deal with all this. Seems like I really should drink some coffee. That's not a zip file that can be actually installed. Wow, this is really nice. They don't have to be zip files, but they do have to be zip files because nothing is happening. Oh! Yes, let's just overwrite that. Yeah, successfully installed library. Yeah! It works! And this is how much fun adding libraries in a programming IDE is for an 8-year-old. Additional boards manager URL. So let's see how that's going to work for us. Preferences. Additional board manager. So we got the uploader board connected to it. Okay, so I might have downloaded the buzzer test program to this at some point. Since it's been over a year, I don't really remember. So we're just getting a lot of gibberish here. But at least it's running some kind of program. So finally some happy news. After spending a good hour finding 0 Google results other than your IDE is broken, reinstall it. I reversed back to version 1.8, so Arduino 2.0 does not work with the older nibble software. So right now it's connected with the OpenCAD software. It's connected via the serial monitor, and we can now see configure the EEPROM. Reset joint offsets, yes, no. So now we can start doing configuration of the robot CAD. Finally. We have reached the point where we need to connect the wires, and for that, there's a huge guide on here how to do that. But on the forum, I found a easy explanation that somebody colored it up and showed on the board how to connect these older versions. So let's just do that, and we'll switch a camera angle onto looking onto the robot now.
Connect wired.
As April stated, right now we have to connect the servo wires. So we have the red numbers, which is also used as the calibration ref. On version board 0.2, that brown is down towards the board and orange is upwards. And tail should go to 2, mounted to the last pin header here. It just barely fits. It's really a tight fit up against the wooden frame. Doesn't connect that great. So I guess this is going to be quite a lot of fiddling. Wow. I think I mentioned this before, that this really requires pliers or very small fingers. So maybe I should let April do this. Okay, so now I mounted the tail and the head. And we would like April to mount the rear thigh, which is this one. So April, you have to now take this cable and mount that is 11. 11 has to go to that one, so the second last one. Nope. You see brown wire, red wire, orange. Brown has to be down. And you have to put it here on that third pin. So you have to twist it like this and then put it down into the pin header. Okay? Yeah, almost. Yes. But see, you missed one pin. Take it out again. Right, you got it perfect. So now we need a leg. So now you put 15 onto here. Yep. We continue over here with 12. So 12 go there. Then we need 8, which is this one. Goes there. Perfect. Then you mount 14 there. I can drink some coffee while you can enjoy April's nice drawing of the cat here. That is 9. 9 goes there. $13 to go in there. Yes, correct. Now we need the head. Now the motor needs to connect here. That's 1. Good. So now we have some kind of cat put together here with limps all over. Alright, we now have the joints all connected up. Trying to video this with 2 different camera angles, probably not succeeding that well. But now we're ready for the calibration. And for this we of course need to first upload the entire program. So we have to uncomment the main sketch, then upload that to the CAD, and sketch too big. Ah, damn it. Why is the sketch too big? We're using something like 200 bytes too much. Okay, so have to check up on that first. After we kind of failed getting the Bluetooth module to connect to the old version board that we have in the nipple, then we reached out to Kaizer and asked how this Bluetooth module is supported by the older version board, and it turns out it's actually not, despite being told so in the documentation. So we reached out to them and we got a new board with a discount, and we got a package from them. So now let's open it and get it installed in the CAD. Lots of bubble wrap and more tape. Well, we can't be mad about good packaging. The new board. And of course that leaves us with the small quest of taking the complete CAD apart again and get this installed into the CAD again. We changed out the new board that we got from Kaizer, and now we need to change the wires on the
robot cat.
Coffee for the father, and I will let my daughter try to mount the wires. So let's get down to the instruction here. As we can see, all the motors have been numbered to 0 to 15. Motor 0 is the one for the head. Perfect. Wire 1, which is for the head. Also the first one. Then we have 2, which is the tail. Now the wiring did change from the first board to the new board, so yeah, this one is in the wrong place. We need to get it to the other side. So the next one in line would be 8, which is this one, the shoulder. One. Then we have 9, the shoulder on the other side. Back left leg, the shoulder. That needs to be connected, that's number 11. So you have to, that has to be the number 2 spot from the front, yes. Perfect. 12, which is the left front leg. 12, 13, 14 and 15, they all go to the inner ones. Don't touch the circuit board. Coffee. the left back leg. Perfect. That should bring us closer to the calibration process. So let's see what the it says here. Okay, plug in the servos, wiring. Okay, so now install the head, tail and leg components as following picture. Don't install limbs without first time calibration. Now what is first time calibration? You must enter the calibration mode before installing the head on the legs. After entering the calibration state, you need to attach the head, tail and leg components to the servo's output. Don't screw them yet. Okay, use the joint calibrator in the Pedal desktop app. Now that's something we have. And then with the new USB programmer or USB adapter we got here, along with the new board, let's see what happens. Okay, it starts to play some sounds. Maybe we have to give it a firmware. Yeah, let's just do that. And it's upgrading.
Up.
Reset joint offsets. Yes, let's see what happens. Okay. It's pretty nice with this new interface they have made that you don't have to use the calibrate EMU, lay the mainboard flat on a table. So that's calibrating as well. Okay, now it's updating the main function. Firmware upload complete. And then it just keeps playing music. Okay, joint calibrator. Waiting for robot to boot up. Connection failed. Could you try to unplug the cable and plug it in again? I'm not sure why it refuses to connect because it is COM3. Oh! Now this is shown for the biddle and not the nibble, the cat. So I'm wondering, did we not choose that? Have to choose it's a nibble? And then it might connect up.
It's yellow. Lace. It's not.
The lights are on. At least it's playing a lot of music, so we know it's alive. So maybe it will show the correct interface now? No. So it's a bit weird that it's not showing the correct interface. I assume it has to, but why it wouldn't change to the right one? I'm not sure. We need more coffee because building a robot you actually need to read the manual, and the fun thing is that while we kept getting into the biddle state in the joint calibration is because we did not install the batteries, so the robot were not booted. That's why it went into manual mode, and that apparently defaults to the biddle joint calibrator. Oh, we have to actually turn it on now. Ah, man. Okay, so yeah, there we have it. Now it boots up into the right interface. And if we move something like the knee, and then we will calibrate from a more center position. It's like the head gets a bit stuck over here in the up against the wooden parts. We might have to cut that off. The head pan. Yeah. So head looks good. But the head tilt something is clearly stuck. Now we need to get ahead with the joint tuner and do the actual calibration. But first we need, of course, to mount the rest of the parts. So we need to put the tail on. Alright, there it is. So we can probably press save. So now we should actually be able to tell it to rest, to lay down. Okay, it looks like it's a bit off still. Oh, it went against the battery holder. There, that actually goes up against the servo motor. That's not good. Guess we have to bend that in some way. Whoa! It panics if you pick it up. Oh, it tries to balance. It actually tries to not fall. You can lift it up like that. Oh. Okay, let's just put it down again. We have to fix that. But it also has this walk button. It's going to walk. No. It's very, very vivid. It's like a living creature. It's behaving. It's quite fun. But we have to do something about the battery switch here. Oops! Oh no. Where did the leg fell off. Okay. All the way back. Now maybe it can do the rest. Yes.
Yes, it's there. Yeah.
But it's still a bit off to the side. And press walk. It's probably walking out of the frame. Let it walk back. And rest. Now we found April's tablet. We put the Bluetooth module in. We actually found it on the tablet and matched them up. So now I guess you'll just have to start the app here. And we have some kind of unnamed cat up here. We can connect to that. Okay. Please choose a connection with Biddle or Petoy in its device name. Rescan connection. Because we did actually find the Bluetooth module named Biddle. And of course now we're getting nothing. Did show up as two different Bluetooth devices. So that's the one we had before. So we have a BLE and a SPP. So that's the serial port, and that's probably what we are going to be using, as this does present itself as a serial port. Okay, now we have it.
Yeah.
Please assemble nibble first. Well, I really hope that we did that so far. So let's go to the control panel.
Oh.
Okay, so that's quite a big interface. Guess we just have to turn that tap around a bit. So now we can see it's resting. So we press stand, rest, Then we have say hi. This concludes a 3 to about 4 years building project of this cat since we built the smaller one, the Lion Follower car. Could you start it? The Lion Follower car is quite simple and it's an autonomous vehicle. And that actually makes it a somewhat better project for kids as it's easy to build. You can change the tracks, there's no programming involved. Whereas a advanced and complex project like a robot cat, like this nibble from Petoy, is extremely complex, hard to program, and has a lot of fall pits. So let's just stop the Lion Follower car for a second here. And April, could you make the cat stand up? So if you try to pick it up, grab the frame. So the cat here is quite interesting because it's interactive, that you can make it look at you, and it's doing a lot of stuff when you manipulate it. But the problem is if you put it down on the table again, then it stands still. This is of course something that you can do something about. You can program it, you can expand it with a Raspberry Pi. You can utilize the ultrasonic sensors, which we don't have connected right now, as this is the old original sensor and is not compatible with the newer board. But I think that once you do pick it up, it does have this nice traits of interacting with the world. So it's a very fun little toy once you grab it or when you program it yourself. So try to do some tricks. So it can do a lot of cute things when you just use the app. Just push whatever. That is a victory. Thank you for watching and thank you for following our 4-year project here. That took a very long time to assemble, and as we could see, the progress of the Petoy project did expand very much since we bought it. But it has been a overall fun project, unless you take into account the around 20-30 hours of raw footage that this video is compiled from. It has been a lot of frustration, emailing back and forth with the creators, but have been very helpful. So thank you for watching, and I hope it inspired you to do some electronics and robot projects with your own kids. It is, after all, pretty fun once the result is made. So until next time, see ya.